This conference will now be recorded.
Okay. All right, let's see here. I'm gonna just wait like 1 more minute, I think. All right, just about to get started here for folks who are just getting on. This is kind of like, it's like watching the popcorn pop, you know, when the attendees are rapidly changing. You know, you don't want to start the meeting, but when they slow down a little bit, I think it's okay to start. So let's get going. Welcome everybody to this month's Interoperability and Technology Tech Dive webinar series. As those of you who have been here before know that these are all recorded and our previous talks are all listed here. You can see that over the past year, we've had quite a focus on Jupyter and technologies in Python that enable us to do work in the geosciences, and today is no exception. I'm very pleased to have Martin Durant from Anaconda here talking about a new tool that's being developed actually, that is open source tool that allows us to do some interesting things with making it easier to share and load data. So I'm just going to mention here, if you want to get on this list, if somebody forwarded you this email and you want to get on the list so you get notified of these events, you can go back here. If you just Google on ESIP, IT&I, or something like that, you'll land on this page where you can join the mailing list, or you could just shoot me an email or put it in the chat or something like that. Okay, so actually a special thanks to Martin too, because we were struggling to find a speaker for today, and Martin just agreed to do this last night. But I'm really excited because I've just started using Intake myself, and there's a lot of, I think there could be a lot of interesting discussion at the end of this. So without further ado, I am going to switch it over to Martin. Martin, I'm making you the presenter, and you should now be able to share your screen.
Yep, let me know when you can see it.
Yep, that looks good.
Okay, this is the same talk that I've been giving at conferences recently, so it's a bit generalist. There's nothing special in here to do with scientific data or anything like that. Intake itself is quite a generalist package, and I'll describe the general use case that we have in mind here. I should say up front that this is funded by Anaconda. It's fully open source though, so you can get involved. Issue tracker ideas are all welcome. Intake is new, and part of the reason for wanting to be involved in webinars and conference talks and that kind of thing is to get ideas from the community of what Intake can be, where we can go, so that I personally can develop things that are actually useful to people. So it's a good time to get into the conversation, to figure out the best things that Intake can be doing. And if you like some of what you see here and you have some suggestions, then please come forward. Both at the end of this talk, we can talk about it, and also on the issue tracker or any other way that you want to get in touch. There is also a Gitter channel for those that are interested. So I'll start here, and as I say, this is a generalist talk that I happen to have lying around. I'll follow it up with a couple of short examples of Intake in practice, but this is a typical code cell that is something like what many people might have written in the past. It might be at the top of a script, or it might be in a notebook or wherever. In this particular case, this concerns loading a bunch of CSVs into a particular data frame. That's all this cell is doing, and it uses Pandas for those that know what Pandas is, it could equally be a load of arrays or text data or whatever it is. You will very often have something that looks like this. You have some file names, you have some location that you have to get them from, and you have some lines of code that are actually going to get them and stitch them together in some particular manner. Many people in a given organization will have ideas about a code cell that looks like this. I'm going to cycle through some comments that various different actors might have about this. I do want you to keep in mind that if you're an independent scientist, then it may well be that you are all four of the people that I'm going to mention here. But in a bigger structured organization, typically you have different people doing different jobs, but all have interests in how data gets into memory and gets used by people. So first of all, there is the person who actually is going to execute this cell. I'm calling them the data user. In a corporate setting, this person would usually be an analyst or a data scientist, and they don't want to have to write this stuff. So they're annoyed at the length of this cell. The longer the cell is, the more opportunity there is for errors to creep in, as is always the case with code. And secondly, let me, I should get rid of my notifications. Anyway, secondly, the only way that they have to reference what is it that's actually being pointed to by the cell here are the file names, part 1, part 2, part 3, not very descriptive. So you can never be sure, is this actually the right data set that they wanted? If they want a different data set, how do you go about finding that data? So these are current pain points that anybody who uses data has to face. And secondly, there is somebody who is in control of actually making data available to the organization, and they might have concerns such as this. Oh, you're accessing some data, but actually that's no longer the reference data that you should be using. There is a newer version. What's more, this newer version maybe is in a different format, it's on a different storage system. In other words, the code cell that the data user wants to execute is incorrect. It's not what they should be using anymore. This is a problem, so the data provider doesn't now just have to put the data in correct places, they have to somehow disseminate how to access this new form of the data, and in fact, some way to tell the user that this new data exists. So these are additional problems. Now, thirdly, if you have security concerns at your institution, then you will have thoughts like this. Oh, we see that you need to be authenticated to use this particular data service. In this case, it's just a simple HTTP endpoint, but it could be any number of things. And there are some specific credentials included in this cell. You shouldn't be doing that, obviously. And in fact, what if this is not actually the right person? They've just copied and pasted this code cell from somebody else, and credentials are being copied and pasted across the organization. This should never happen. It should never appear in the code itself. It's against all of the good coding practices that we know. So that's another problem. And then finally, what if, now the example that I'm giving here is Pandas, and I'm saying perhaps the data has been transformed from CSV to Avro. What if the software library that you want to use doesn't actually have a reader for the particular data format? Somebody's going to have to write that. And in fact, that also applies to the backing store. So it's now in a different backing store. Perhaps you're going to need some code to be able to access that. It's not a simple HTTP anymore. These are all problems that happen every day, and a huge amount of time is wasted in sorting these things out. So this is where intake comes in. The form of this particular code cell under intake might look like this. You have some specification, in this case within a YAML file that I've just called a file. This is a local file in this case, but there are a number of different ways in which you can specify where a catalog is, where the specifications of data sets is held. Assuming you can open that, then all you need to do is you have some named data set. I'm just calling it useful data here, and then .read. And you have your data frame in this case. A number of different things possible to load using intake. It could be arrays, it could be Xarrays, it could be generic lists of things, or it could be data frames. Those are the current possible outputs, but more could be done in the future. And obviously this code cell is simpler, but it actually speaks to all of the problems that we've had before. And I can demonstrate in the next few slides how that actually works. So as a reminder, here we have the data user. This, according to the internet, is what a data scientist looks like. So obviously we draw geometric graphs all the time and whatever else. If I had searched scientist without the data, then it would have been probably the same, but with a test tube, so that's fine. And they want to know what are the data sets that I can be reading, of those which is the right one to do the job that's in front of me. And finding out which is the right one involves not just knowing what names are there, but you want descriptions, text descriptions, metadata about what's contained there, lots of things about the data so you can find the right one. And then once you have the right one, you of course want to be able to load it and get on with your job without worrying about what particular library you need to do that loading, all those things that come in between. So in intake, this looks like this. The same code cell is on the right as before. So this is pretty minimalist. You can also conda install packages, and I'm going to show that in the examples shortly. There is a little notebook GUI. There are probably more GUIs coming in the future. This is the notebook version. It's very simple, but pretty easy to use. And you can just load your catalogs. You can click on your data sets and you get some minimum information about them. And by selecting in here, you can then load them easily on the next code cell. So that's very handy. There are also built-in quick plots. So for each of your data sets, there may be some predefined plots that are good examples of what is actually contained within that data. So that makes the task of finding the right data much faster. Secondary, the data provider. So this is, again, the person that is in the business of encoding data and putting it into locations that are accessible to the users. They want to be able to inform users. They need to know what is there, so they need that for their own records, but they also need to maintain the data inventory, update what data is where, how you load them, what the metadata should be. They are the person that's in control of that. So they are going to be the people that create catalogs. So what do I mean by catalogs? This is a pretty pivotal concept for intake. A catalog is something like this on the right. This again is a YAML format, which is the default format for describing catalogs, but not the only thing that's possible. And a lot of information is encoded into here. And now the task of the data provider is to produce these catalogs. Again, I'll show the process in an example shortly. And the idea is that in here, you can encode everything about your catalogs so that it's in one particular reference place. Everybody that wants to use this data will load this reference and use just this one place. You don't have copy and pasting. You can, in fact, update the entry in place if it's on some common shared location. So then whoever uses the data will automatically always be using the latest version of the data with the best parameters. And that also then covers the dissemination part. So there's lots of details included in here. We can go over what this actually means later, but all I want to say for now is that this is fully descriptive. You have descriptions, you have what parameters you can use, you have arbitrary metadata, and you have the thing called driver is what is the code that's actually going to load this, and you have some arguments. So this is a full encoding of what do I mean by this data set, which in this case is just called entry 1 part. That's an example. IT departments within institutions concern themselves about who can get to what data, how do you authenticate people, what data is allowed into the system. For most scientists, this is not as much of an issue as in a corporate situation, but if you work for some government agency, perhaps, then it might be. Intake doesn't have a huge amount of built-in tooling, but it does have some good convenience for an IT department's point of view. For example, you can automate user credentials, have them as be parts. This again is an example. Secure data set in this case, where you need credentials, and these credentials are going to be taken from the user's environment. This is one possible use case. You have this default parameter value is going to be taken from the user's environment. It will be just the username in this case, but you require the user to provide their own password. It's one particular possibility, but there are quite a few that can be made, and Intake is very pluggable, so you can come up with new authentication mechanisms and add things into this if you require them. Also, there is an Intake server, so you can be the data gatekeeper also and stream all data through this server and have arbitrary authentication mechanisms there if you want to. And then there's the lowly developer. This again is apparently what a programmer looks like according to Google, which is reasonable, I suppose. I don't like that hunch, but what can you do? Your developer would like to not rewrite code again and again, would like to be able to hook into libraries that already exist, but to offer a consistent API to the user so that you don't have to train the user every time that you create some new data loading code. Intake, again, because of it has this pluggable architecture, gives you a framework within which you can phrase code that's going to load data, and you get a lot of things for free when you do that. You get the ability to load data from remote data sources with automatic lobbing and file name parsing. You get cache on first download. You get Dask functionality, maybe. There's a lot of things that Intake will do for you, as well as, of course, then you can express your data sources as catalog entries. So these things all fit together quite nicely within Intake. That's the idea. I more or less said everything that's on this slide, but on the right-hand side is a data driver. So this is to regard a particular set of issues for a particular GitHub project as a data source, demonstrating that we're not just talking about files here, we're actually talking about data services too, possibly some arbitrary HTTP API, like in this case. The amount of code that you need to write to take some third-party library that understands the data already and turn it into an Intake plugin driver is actually very short. You really don't need to do much to intakeify something that already exists. Or if you want to write data ingest code from scratch within the Intake framework, then it's not going to add much difficulty to your coding than you would have had if you just wanted to say output a NumPy array and be done. So moving on to some examples. Now I'll come out of here. I can close that. I've titled this data science, but obviously science in general is rather similar. So in this particular case, well, that didn't happen before. Excuse me while I switch to a different environment for a moment. I should have something appropriate here. Are we okay if I pause? We can have questions and answers for a little bit. I'll just build a quick environment that doesn't have some bad updates that I apparently did recently.
Sure.
This conference will now be recorded.
Okay. Let's see. So if folks want to ask questions, I've currently muted almost everyone, so you can go ahead and unmute yourself. Actually, it occurs to me that it might be, should we just wait until you're,
I can answer questions while I type this.
okay, actually, I think we lost, did we lose your screen share? I think I lost
Yeah,
your
I turned it off because I thought you wouldn't be
Ah,
interested
okay.
in watching me type.
Okay. Oh, okay, that's fine. So I guess the, you're showing this obviously for Python. Could it also be used, say you're an R user? I mean, is there anything? I mean, I suppose there's a little bit that makes it Python specific, but could that be? Could someone using R, use some of the same technology?
So the implementation is certainly Python. The idea of having a catalog where each entry is basically take these arguments and pass them to this function, that is pretty universal. We don't have any plans to try and make an R implementation around that though. So
Sure.
at the moment, it's Python code that loads that catalog, and it assumes that these drivers refer to something that can be found in a Python module. You could make something. Yeah, it relies on whoever is making these specifications understanding the driver that they're going to call. So if you have a CSV driver in Python and you have a CSV driver in R that happen to, because you've carefully considered this, happen to have the same arguments, then you could have the very same block be executed by intake R. But in practice, I don't see that happening in the near future.
Yeah, there'd be, but so if you were going to do this, say for the R community, there would be some similar sort. You might take the concepts and the architecture or something, but implement, something for that would perform the same functionality, perhaps in R or something, I guess.
Right. Yeah. Yeah. So there are lots of catalog-like things in existence, actually. I have a slide on this, but there aren't that many that try and cut across the. Basically, intake is tying together lots of other libraries. That's really its job. And Python is particularly rich in having lots of these libraries, as they tend to be independent things. So for example, this GitHub loader project is something that exists on GitHub itself. Somebody has bothered to make that. I don't actually know the R ecosystem that well, to what degree it's like that you have lots of these independent projects that are hoping for some framework to reference them. Do you see what I mean?
Sure. Yeah, I get it. Yeah. No, it's really interesting. I think this is. I can tell by from some of the people who are here on the call. It's very interesting, sort of seeing this approach because, some of us in the government, and have been involved with, well, not just the government, but involved with like the OGC and sort of community-based standards for delivering data, like the OpenDAP convention and CF conventions on top of OpenDAP, and it's kind of taking this approach of trying to standardize the data stream for different types of scientific feature types, certain types of multidimensional data with certain kinds of metadata, things like that. And this is sort of an approach to kind of deal with everything that doesn't do that, I guess, mm-hmm. In a way. I guess it's more than that, though. Have you got your environment built yet?
I believe so. That's...
If you do, we need to switch back to the to having you share your screen again.
Yes, I think this is working.
I guess this is the this is something that happens sometimes when you have a very new package.
So it's not intake that failed. It's because I updated some plotting libraries. Yeah, that is completely unrelated, but it was in the same environment, so that's what happened.
Yeah, yeah. Are you using CondaForge?
Yeah, I believe it's to do with Bokeh version 1 is actually a fault here, but I'm not quite sure what I did. So yes, I can show again. Do I need to click on something to make that happen?
Oh, I'm sorry. Maybe I have to. No, you're the presenter, so you should be able to share your screen somewhere.
Oh, yes. Okay.
Okay, there we go.
Okay. So now the import worked. The point of the demonstration was that you can actually Conda install data packages using intake. So, or I should say, intake is compatible with Conda as a way of installing data, which is quite cool, and it means that you get the benefits of Conda itself. So your package can state its dependencies, which is very convenient. And you have versioning, and you have a way of distributing your data package. So not just code is what we usually think of for Conda, but now you can actually view your data artifact as a versionable thing too, which is very useful. In this case, I did this install line, or I created a new environment as it happens. And this made available within intake.cat, the built-in catalog, an entry called US crime, which is this default example data set. And you can work with it. So you can view it. It's just and you can look at some basic information about it. There's some descriptive stuff here. It's basically telling us where the data came from.
And so you haven't read the data yet, right?
Yeah. So this first one is just information contained in the catalog itself, and the second one actually looks at the data. Discover is supposed to look at a relatively small part of the data, as much as is required to get basic information about it. Exactly how much gets read will depend on the type of data that you're looking at that point. In this case, it's a data frame, so we have a load of data types here, field names and data types. Also, interestingly, we have this plots metadata entry. This is telling me that there is an automatic plot available that is called example. And so to get this quick plot, I just do .plot.example. This is the name of the thing that is defined up here. And this specific plot showing robberies and burglaries over time in the US. So 1981 was a bad time if you had stuff that could be burgled, apparently. This is also built into the catalog itself, and this is a useful thing to provide if you're writing the catalog so that people can get a quick feel for what the data is that you're distributing. Or you can do typical things. So this is the quick route. You just say read, and now you have a data frame, which is a normal data frame in memory, and you can do all the things that you normally would do with a data frame. Or it could be a NumPy array, or it could be an Xarray. And for most plugins, you also have a toDask method if you want to use parallel distributed functions to work with the same data, which is obviously very useful if you have data that doesn't fit into memory. Not all drivers necessarily support Dask, but certainly the ones that I write, and I would encourage people who write drivers to consider Dask as something to support. Dask is quite easy to support if you're already reading conventional data formats that can be expressed as arrays or data frames or Xarrays. And the final thing that I'll show here, I might not have installed this. Oh, I did. Okay. Phew. Is the GUI. So I only have one built-in data set here, so that's the only one that I can select. But actually, I can load either local data set. So this is one of the test ones that comes with intake. Let me try and find it. I have quite a lot of libraries. And catalog tests. So I could load one of these catalogs, and it appears here, and it has various entries within it. As an interesting thing here, in fact, that one of the entries within this catalog is a reference to itself. So you can embed catalogs within catalogs and have a hierarchical structure. Actually referring to itself is not very useful, except if you happen to be running tests, which was the point here. But I can click on this and it appears here, and it happens to have exactly the same entries. But it could be a master catalog that refers to several other catalogs. Those other catalogs don't need to be local. You could have all of this. So the second example is actually pointing to the Pangeo catalog. So you can just stick this in here, and this also gets loaded. So these are the Pangeo datasets, which are various things in Xarray, and the NetCDF ones will not load remotely from here, but the Xarray ones certainly will. So these are this is a very simple, useful way to point people to your data. So that's it for the end user's point of view. You really don't need to know more than this. Are there any questions on that before I move across to the before I run across to the data engineer version?
Could we see the plot, the example plot again? Like, how did you know, like, what plotting tool? Do you have to specify that as well, like what plotting tool to use in the metadata?
So this is using hvplot always, so you don't have a choice in that.
Okay.
If you load it into Pandas, then of course you can plot with whatever you like. But these built-in quick plots are using hvplot, HoloViews, bokeh.
Okay.
Which are dependencies, so you expect them to be there. And this specification of what the plot is doesn't specifically say that it uses hvplot, but I suppose we could consider other plotting outputs in the future. We just haven't done yet.
Okay. There might be some namespace or something, I suppose, or whatever. Yeah. All right. Or namespace like that. Yeah. Okay. Anyone else? All right. I guess we can move on.
Okay. So I'm calling this data engineer. Again, it's basically the person that is going to create catalogs. In intake, you have a certain number of drivers. This is a new environment, so it doesn't have that many, but you could have quite a few. And for each of these drivers, you have a function called open underscore whatever driver it is. So CSV is most of these examples are CSV because it's built into intake. You don't have to install anything else. And it's the most common tabular format out there, certainly. There's an awful lot of CSV in the world. This is CICE extents by year, I believe. So I can just show it here. I mean, I don't actually know what this data is. It's not too important from our point of view here. The point is that we've created a source by calling this intake open function. Really, this is just calling read CSV underneath, but this source object, the fact that it reads well, tells us that the arguments that we've passed to it are reasonable arguments. Obviously, for CSVs, there are a whole load of other arguments that you might want to provide here. So there's lots of optional things that I could put into here. You would want to read the documentation of the CSV driver itself and whatever library that it depends on to figure out what all of those inputs could be. And they're going to be different for each of your drivers. So if you're using Xarray, then the various open functions that come from Xarray, which are these. You have CDF, raster IO, Xarray. These are in the Xarray intake Xarray package, and you can read the doc strings of that to figure out what optional parameters you could be passing down to the reader itself. So the point of doing this, again, this is a very similar plot to what we saw before, different data. Here I'm explicitly calling HV plot. So this is calling that library. And the reason for doing it is because the plots that I might encode into the catalog are going to be using HVplot too. So these are exactly the same set of arguments that I would pass in the catalog prescription. And I'm going to do that right here. So first of all, having loaded, I use this open_CSV function and made a source, and then I can look at the equivalent YAML representation of the source that I made, and it looks like this. It has no description, it just has the arguments and driver. And then you would take this and fill it in with whatever is appropriate. You want to give your source a decent name, you want to describe it, you maybe want to add extra arguments if you need them, and in the metadata is where you put any plot information that you want to do. So this is the final version. It will look like this. So as I say, the description here is short, and I've just basically added in the same plot keywords that I used above, just as an example, so that now to test it, I can open this same file that I just wrote, and I can do exactly the same plot. This is now just showing that I've gone through the process of investigating a particular data set. I figured out what driver and what argument I need to load it. And in this case, I've gone to the trouble of figuring out a particular plot that shows the data quite well. And I've put it into a file so that anybody else can now load this file and they have access to the data. I can put this file into some shareable place. So in this case, it can be on GitHub, which is somewhere that everybody has write access to, or a gist, for example. You can always put files there. You might put it on S3 or Google or wherever your internal shared disk, perhaps. And that is a way of letting people have access to the data. Or you can make a Conda package, which is what was demonstrated in the other example. And now that the catalog is in some GitHub location, you can load it. It's exactly the same stuff. You can look at the data. Here's the data. One interesting side effect, and I'll finish with this, is that the catalog itself, so I've loaded this catalog, and I have this cat object, which contains the entry that I just made. The catalog object itself also is a data entry. So I can include this thing within another catalog if I want to reference one catalog from another. That's how you would go about doing that. Okay, I've talked, I think, longer than my half an hour plus a few minutes for the small technical hitch. So yeah, I came here because I want ideas. First, you might have some general questions. I can talk specifically about science use cases if you want to. But yeah, I really want people to be interested and try it. I can switch back to my presentation, and well, I can show you this are the current set of plugins, which is actually out of date now. A summary slide, I don't need to go through this. I think I've said enough. Intake is there to connect together all the different useful data packages that are out there in the Python ecosystem. But this is the main takeaway, is that try it, comment, make your opinion known, and get the conversation going.
Great. Oh, thanks. That was a great presentation. Really very clear, and there's obviously a lot of functionality there that you covered in a relatively short amount of time. I had just had one quick question about the I guess sort of the development future of this. Is this something that was funded, for a year that somebody wanted to pay for? Or is this something that is of general interest to Anaconda, that they sort of built it for their own purposes, that they basically needed something like this and they're sharing it with the community and hoping that others will help develop it? Or what does that look like?
The answer is all three. You only said two, but I'll tell you the third. So yes, there was external funding for some of this, and that is reflected in the particular choice of drivers that we wrote first. So the external funder had some requirements about that. So there's quite a lot of systems monitoring and data service drivers at the moment, which may seem a little odd to some people, but that's where that came from. But actually, this was something that Anaconda wanted to do for two reasons. One of them is that from Anaconda's point of view, the more people that are doing data stuff with Python, the better. So the more that they can do to help the open source community be a rich community and not force people to use non-Python tools to get things done, the better. So this felt like it was a real need. Cataloging is something that doesn't exist in the Python world. There are third-party catalog tools to some extent that exist, and I'm thinking of things like a SQL database has a concept of tables, and that is a form of catalog. But you also have things like online data services that host your data, and then you have some interface with that. Intake is trying to make it really simple. You don't have to buy into a system. You don't have to deploy anything. It's just the import, and then it's there for you. So the real thing that we need to make this be a thriving ecosystem that is good for all Python open source is people to get involved, to make data catalogs, and to make drivers. Because I could spend all my time making catalogs and it would only scratch the surface of everything that's out there. There is an awful lot of data, and if we can surface it to people in the Python data ecosystem so that they can play with that data, then that is good for everybody. But yes, there is also the third. If we can get people comfortable with the intake catalog idea, then if they're considering an enterprise data science platform solution, then Anaconda provides one, and the step that they will have to take from using intake in the wild to using the variety of intake that will eventually exist within that platform will be much less. So it should be comfortable, and they would be happier to take the Anaconda TM enterprise solution because they already understand the cataloging system.
Awesome. Yeah. Okay, that makes sense. So ideally, it's one of those win-win-wins, right? Win for Anaconda, win for Python, and win for the community.
Hope so.
Yeah.
There is no strict runway on funding. So the external funding is done. That was done in the summer, and that's why we started to talk about intake only after that was finished. Anaconda wants to see this succeed. They want intake to become a thing. Obviously, if there is no uptake at all in the public, then after some time they will decide to go in another direction. So I can't give you a concrete answer on that.
Right. Okay. Folks, just a reminder that you need to unmute if you want to ask a question. There is a question here in the chat. How does intake handle different levels of data granularity that may not necessarily be files? And I think then says, for example, the threads data server and netcdf subset service, those might not be things you're familiar with, but they are like OpenDAP, say could come from a threads data server.
Yes, I've seen the threads thing. Actually, there is Threads came up because there is a rudimentary Jupyter Lab pane that connects to a thread server, and the initial ideas for making a GUI for intake were taken from that. And I don't really know how Threads works and OpenDAP and those things. I know that Xarray has some interoperability with OpenDAP. Is that right?
Yes, actually, I think the answer might be. Let me just see if this makes sense. Is that because you have a intake net CDF reader, I think, and that can be read, that can be put to Dask, that you could open up an OpenDAP endpoint, which looks like a remote netcdf file, and you could then you could open that with intake and then just treat it as if it was a local, well, you read it into Xarray, and then you basically just have an Xarray data set, which accesses the data via OpenDAP when you need data from it. Isn't that right?
Yeah, well, the short answer is if Python can read it, then so can intake, because all it's really doing is calling Python functions. If you want to make it into something Dasky, so then you may need to do a little bit of extra work. For example, you probably know for netcdf files, reading remotely is a difficult thing, and some of you may know I was involved in Fuse solutions for that kind of thing for getting that working. If OpenDAP is something that you run locally and you expect Python to be able to read that data without problem, then you can make intake do exactly the same thing.
Yeah, I think that would be the case. In fact, I typed into the chat window that PyDAP is another way to get OpenDAP stuff into Python code over the network. And one thing that's really interesting about PyDAP, as opposed to going through the netcdf interface, is that netcdf is essentially limited to arrays, but PyDAP supports sequences, which are tables, which mesh very nicely with data frames, for what it's worth.
Oh, that is interesting. Yeah. Okay.
If you would like to have a go at coding that up, I would be very happy to see it.
I would love to have a go at coding that up, no pun intended. But and actually, maybe I will. I've been doing a bit more Python sort of on the side, but it's not really my day job, so I got to watch that. There you go.
So there was also the question about granularity. So I'm not quite sure what that means, but basically, some of the drivers here are definitely oriented towards loading specific files from a remote data service. And that remote data service is a file-like thing, so S3, for example. And many data formats are like that. But if you have a data service of any sort, and the GitHub API is a really simple example of that, then you will get the capabilities of that service, basically. So if it's something like we've mooted a connector to Immuter, and Immuter provides normally SQL, but with strong guarantees over access controls at the column and row level. But they do that internally. So from the outside perspective, you're just executing SQL calls on some HTTP endpoint. And if you were to build a driver for intake to do this, then you don't need to know anything about the details of what's going on behind the server.
Right. It's pretty interesting.
There's another question. It says it looks like you need hvplot installed. I guess that's yes. If you want to do the plotting, you need hvplot, right?
Yes. So hvplot is the thing that we're using, and it's not a required dependency.
So I don't know if somebody else on the line might have some insight here, but we in this community, as I sort of mentioned before, there's a lot of when we think about catalog, we think about things like data.gov, these basically catalogs of metadata that you have standard services to query on, and you do some geospatial, temporal, faceted search, institution, whatever variable you're looking for, and you get back a bunch of metadata records. And in those metadata records, you might find, like we might hope to find now, say an OpenDAP endpoint, something that we know how to access data from. To make that return something that connected to intake, I guess you could imagine, embedding like an intake catalog or something, I guess, in the metadata, or maybe providing a URL, I suppose, to an intake catalog.
You actually don't need to do that. The simple route for something like that, the best example that I currently have is the SQL catalog, which is a class. So it's a data source which acts like a catalog, and all it does is ask a SQL database, hey, what tables do you have? And for each of those tables at runtime, it creates a data entry, which is a pretty simple thing. So you could do the same for whatever remote service you want to connect to. You can run a query, and the thing that you produce on that query is a catalog at runtime. So that's then you need to obviously pass the whatever format of records it gives you back, and pull out the piece of it that you actually need to access the data. Did that make sense?
I'm not. Maybe I don't think so. I'm not sure that. I don't know, maybe somebody else could chime in and help me out here. But I guess what I was thinking is, if you started out at data.gov, and you did this kind of query for a particular type of data set, and maybe it is some gridded, like maybe it's one of these Pangeo data sets you end up discovering. Mm-hmm. How do you get from there? How would you enable a search that started at data.gov to end up with your, intake catalog metadata?
Yeah, so essentially you would need to have a little bit of logic which is capable of doing the search itself. I assume there's an endpoint that you can call, and taking the output of that and creating an entry object. So the entry object needs to say what will load it, and it needs to say the arguments to pass to it. The what will load it, I assume in each data resource it says what it is. So if it's a OpenDAP thing, then we know we're going to pass it to PyDAP, for example. Maybe there's a limited range of data types that you handle. And then the URL or identifier that's built in there, that is the argument that you're going to pass to the loading function. So this parsing logic will end up being rather short and simple. And the intake framework of building these plugins, these drivers, is simple enough that you can drop a piece of code in there, piece of logic in there as a method, and have it look like a catalog from the intake user's point of view. Perhaps this is a case study that we can flesh out. We could make so I don't know how data.gov works and what exactly you would expect out of it. If you were to make an issue of this in the intake repo, then I could at least put down in something more concrete how I would go about solving it, and maybe I'll have the time to actually solve it. Okay, excellent. I will take that approach and think about it a little bit more, because I haven't really thought about it too much at all, actually. So that's good. And the SQL version, which is of course a pretty simple case, is a good place to look. So the SQL catalog does this, but for a very well understood case. Looks like Joe Hammond is ready to ask a question.
Yeah. So hi, Martin. Joe Hammond here. I have one question, one comment, or maybe two questions. on the last point, so basically what you're talking about is kind of converting something that can act like a catalog, but not an intake catalog, and then have it give a front end that looks something like an intake catalog. Is that another way to say what you were talking about there?
Right. It's an interface that acts exactly like a catalog, but it doesn't need to be a YAML file anywhere. You could take those details and write them into a YAML file, but I assume there are far too many data sources on there to want to do that. You actually want to run dynamic queries.
Right. So another use case, and actually Anaconda is going to have some money to work on this with us, is the NASA Common Metadata Repository. So it's basically a catalog of all of the assets that NASA has. And we've been talking about putting an intake interface onto that. So, that might be a nice use case that we actually will have some people to work on in the short term. Okay, so my other question is, what if you could maybe talk a little bit more about the intake server and what the use cases are there, how that works?
Yeah, so I have been leaving the intake server mostly out of talks like this because it's quite complicated, and part of the motivation for intake is to make it as simple as possible so you don't have to deploy anything. But the intake server provides a simple HTTP protocol over which you can fetch data specifications. So it's another thing that acts like a catalog. And the thing that I provided here, in the example, I read a catalog from GitHub, and it was just some YAML stuff that could be passed. I could equally have loaded that catalog using a server. By server, I just mean it's a process running somewhere on some machine. That loads the catalog. You can ask that service on a particular HTTP endpoint, what data sets do you have? And it will give you these data set prescriptions. And it will look to you locally like any other set of data sets. So they'll just be catalog entries. There are two modes of operation on those. You can either take that data specification and load it directly. So for example, if it's something that lives on S3 or an HTTP or even on a shared disk, it can just be a URL path to that location and some arguments for how to load it, and you can just load it. And this is interesting because the server gives you a monitoring point where you can check who is wishing to see which data. You can see that in real time. So that's quite interesting from an institutional IT point of view. There are also access controls that you can put on there. But if the data itself is in a public place, then that is, of marginal value. The stricter form of this is that the server itself loads the data. So if you imagine your server being as an actual gatekeeper, the server loads data on demand, partition by partition, and the client reads those partitions one at a time. So now you have an actual access and monitoring point to the data itself. This also helps with the case that you have some file format that it has no convenient way to be sent across a network. So actually, HDF5 is one of these, that the standard Python driver, at least, doesn't operate remotely. And there are various solutions to that. Intake would be a really simple solution to that. So you have your server, which can access the files directly and can load them. And to the client, it just looks like a remote Xarray data source. But you wouldn't even know, in that case, the details of how that's being loaded. You just know what type of data it is, the output type of the data, and you can load it partition by partition and access the whole thing that way. So that's a nice convenience. In reality, the current server implementation is very simplistic. I'm sure it does not stand up to very large loads, the idea of it is to show an implementation. So if a serious scientific institution or corporation wants to implement a heavy-duty server to do this job, they can do it for their specific requirements. Still there?
Yeah, thank you.
Were you, Joe? Are you thinking about? Are you guys thinking about that for this NASA project?
A little bit. Yeah, I think there's some elements there, and intake might be able to play into it. I'd have to put a little bit more thought into it.
Yeah. All right. Well, it is 4 o'clock. Thank you very much, Martin, for agreeing to give this talk on short notice, and it's a really fascinating project that I think probably everybody on this call will go back and study a bit more. And we've all encountered all these problems that you mentioned in the beginning. So it's great to see tools like this emerging. Thanks, everybody. Thank you. And we'll see you next month. And this recording should come up sometime tomorrow.
Okay,
Thanks
great.
again.
Thanks, Rich. Thanks, Martin.
Yep. Bye. Bye.